Alrighty. Welcome again, especially to those who are just joining. So we are about to begin and we are on homologous series. So we are on organic chemistry. The whole topic of organic chemistry is all about carbon containing compounds. That's what organic compounds are. And we nickname the ones that contain just carbon and hydrogen. We call those hydrocarbons. So this morning, we reviewed and talked about the fact that carbon has 4 valence electrons, so it can form 4 bonds. We also learned about the idea of a functional group, which is the group that it's a particular group or a particular bond that is responsible for the chemical properties of the compound. Finally, we learned the difference between saturated and unsaturated compounds. So who can tell me what is a saturated compound? What is a saturated compound? Anybody? Saturated compound. All right, I see you, Dustin. You said a compound that contains only single bonds, and that is correct. So therefore, what is an unsaturated compound? What is an unsaturated compound?
Contains double or triple bonds.
Very good. A compound that contains double or triple bonds. Excellent answer. And we also learned the differences between the types of formulae. So I want you to take a look at this, this formula right here and tell me what kind of formula is it? What kind of formula is it? It is the structural formula, and it actually says it right here, structural formula or displayed structural formula. And what that means, are you seeing the screen? Are you seeing it?
Yes, yes.
And what that means is that you can see all the carbon, all the atoms, and exactly where they are placed in the compound. All right, so this is the displayed structural formula. What about this one? What do we call this one? What kind of formula is that one? What do we call this one? What kind of formula is this? It's called the condensed formula, the condensed formula, right? So it's condensed because it's showing each carbon, but it is not drawing the bonds themselves. It's just showing the carbons and the different elements, in this case, hydrogen and oxygen, that are attached to each carbon. So we call this the condensed formula. And finally, what about this one? What kind of formula is this? What kind of formula is this? What do we call that? What do we call this, class? We call it the molecular formula. Yes, because it gives the number of atoms of each element in the compound, molecular formula. So we learn.
Excuse me, miss.
Go ahead.
When you're teaching the new part of this, can you text it the group because I was doing something?
Sorry?
Can you text in the group when you're going to do the, I think you called it the naming thing?
We're going there right now. This is just a review. All right, so we have the molecular formula. If somebody else wanted to say something?
Yes, miss.
Go ahead.
What's the difference between the empirical and the molecular?
All right, so the molecular formula tells you the exact number of atoms of each element. The empirical formula tells you the smallest whole number ratio of each element. So for this one, you can divide out all of these by 2. So this is the molecular formula, C4H8O2. But the empirical formula would be the smallest whole number ratio, which would be all of these divided by 2. So you would have C2H4O. That would be the empirical formula. Is that clear?
Yes,
So
Miss.
no two compounds can have the same molecular formula because the molecular formula is really like the DNA or the blueprint. However, you can have several compounds with the same empirical formula because once you can divide out and get the smallest whole number ratio, you can do that for many, many compounds. So right now, we're going to move on to a new subtopic, which is homologous series. So by the end of this class, you should know how to define the term homologous series, talk about the general characteristics of a homologous series, the general formula for the homologous series, and the formula for the members of the homologous series. So hopefully we can get there. So let us first now talk about what does homologous series mean? What does that term mean? Well, homologous series is a group of compounds that are organic compounds that all possess the same functional group. And remember, we said the functional group is the group of atoms or bonds that give the chemical properties of the compound. So the homologous series is a group of organic compounds that all possess the same functional group. Now, let us look at the characteristics of a homologous series. Now, a homologous series can all the members have the same functional group. So maybe a functional group can be the carbon to carbon single bond. That means every member of that series will have carbon to carbon single bonds. Or the functional group can be a carbon to carbon double bond. That means everybody in that series will have the carbon to carbon double bond. They will have the same general formula. We'll talk about that later. They will differ. Each member of the series will differ by CH2. I will show you that. All the members of the series will have the same chemical properties. Why? Because they have the same functional group. And if you have the same functional group, you must have the same chemical properties or similar chemical properties because you will react the same way. Finally, or the last two is that they will change in physical properties as the mass increases, and that makes sense. We'll talk about that later as well. Now, there is a special way to name the members in the homologous series. So we're going to talk about how are we going to name the different members of the homologous series. I'm sorry, I'm having a little technical difficulty here. All right, so are you seeing it properly now?
Yes, Miss.
All right, so let us look at the names. Now, the first part of the name always has to do with the number of carbon atoms in the compound. And the second part of the name always has to do with the functional group. So you can know exactly what an organic compound looks like by the name. Why? Because the name will tell you the total number of carbon atoms, and the second part of the name will tell you the functional group. So let us look at how we name the different organic compounds. Now, if the compound has one carbon atom in it, we name it meth. Meth something. So have you ever heard of methane? How many
Yes.
carbon atoms do you think methane has inside of it?
1.
It has 1, right? Then if it has 2, we name it eth. So have you ever heard of ethanol? How many carbon atoms, sorry, does ethanol have inside it?
2.
It has 2 carbon atoms. And if it has 3, we call it prop. You have to memorize this. Have you ever heard of propane? How many carbon atoms does propane have inside it? Propane. Pro means
Miss,
3.
did you say metal atom?
Sorry, I said methane, ethanol, and now I'm at propane. So propane has 3. If it has 4 carbons, we call it bute. 5 pent. Have you ever heard of the pentagon? Right, that is a 5-sided figure. Pent means 5. 6 is hex. 7 is hept. Tell me, what do you think 8 is?
Oct. I can already see it.
Okay, and 9 is none, and 10 is
Deck.
deck. Right. So you have to memorize these, right? So if it's 1 carbon atom inside, meth. 2 is eth. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is none, and 10 is deck. Now, let us look at the functional group. Now, the name of the homologous series, if you have a functional group with just single bonds, that's the functional group, carbon to carbon, single bond, we call those alkanes. If it contains carbon to carbon double bonds, we call those alkenes. If it contains an OH group, we call them alcohols or alkanols. If it contains a group looking like this, C double bond O and then a O, C and a OH down here, COOH is the short. We call it a carboxyl group, and these are carboxylic acids or alkanoic acids. So follow me now. This compound here has a carbon to carbon single bond. It is therefore called an alkene, an alkane. Carbon to carbon single bond, alkane. Now it has 2 carbons. So the name of it must start with eth. And because it's an alkane, it must end, the name ending must end in ane. A-N-E. So the name of this compound is ethane or ethane. Let me go over that. This compound has a carbon to carbon single bond. It means it's an alkane. That's the functional group. Now to name the compound, you have to count up the carbon atoms inside. And that is the first part or the prefix. And the last part of the name is the functional group, which is the alkane. So the first part, 2 carbons means eth or eth, E-T-H. And the last part is an alkane, so it's ethane. Let's look at this one. This one has a carbon to carbon double bond. How many carbons does it have?
2. Miss, could
2
you go
carbons.
over the first part?
All right, let's do this part and you will get it just the same. So you have 2 carbons. So what will the first part of the name be? The first part of the name would be F, because 2 carbons mean F. And this double bond means that it is the functional group of the homologous series alkenes. Alkenes. As a result, the end of the name will end in ene, E-N-E. So the first part of the name comes because it has 2 carbons, so that's F or eth. And the second part of the name comes from the homologous series ene, because it has a double bond, so we call it ethene or ethene. 2 carbons, F. Double bond, ene. For the first one, it's single bond, but it also has 2 carbons. So 2 carbons mean F, and the single bond mean ane, ethane, ethane, ethene, ethane, ethene, however you want to call it. Let's look at this one. This compound here has an OH group attached to it. O and a H. It also has 2 carbons. So if you have 2 carbons, what do you name the compound? The first part of the compound must be
F.
F. And then, and you know, my battery is finishing. And if you have an OH group, the last part means that it's from the group alcohols. That means the last part of the name is going to end in anol for alcohol, anol. So F, ethanol, ethanol. All right. So the way the compound looks will tell you the name of the compound. Finally, this compound here has what is called the carboxylic group, which is a C, double bond O, and then the C is also attached to a OH. So it's COOH. This group here is what we call carboxylic group. The ending of the name must always be in anoic acid, because this is from an alkanoic acid or carboxylic acid. So alkanoic acid, so it ends in anoic acid, and the first part of the name has the number of carbons, which is still F. So this is F-anoic acid. F-anoic acid. So this compound is called ethanoic acid. This compound is called ethanol. What is this compound called?
Ethene.
Ethene. And what is this one called?
Ethane.
Ethane. Very good. All right. So we're going to practice now some of these naming and exactly what they are called. So
Miss,
you're
can
going
I
to
screenshot what you just showed us, please?
What I'm going to do is I'm going to take a picture and send it to the WhatsApp group. How about that?
Okay.
All right, because my battery is dying and I don't want us to finish without doing this. So I am going to draw the structural formula of a compound, and then I want you to tell me what the name of the compound is. So take a look at this now. I have this compound right here. All right. Who remembers the name when you, how many carbons does this have?
3.
3. 3. So when you have 3 carbons, what is going to be the prefix? What's going to be the prefix in the name?
Prop.
Prop. Very good. Is who remembers so quick? Prop. Right. So 3 means prop. And it has carbon to carbon single bond. So what is going to be the ending of the name? It means what functional group is it from? Carbon to carbon single bonds is a functional group with the homologous series alkanes. So it's going to end in ane. So it's propane. Propane. That is what that one is. Propane. pain. All right. What about this one? What is the name of this compound? That's the name of this compound, class.
I know it ends with "ane."
Miss
How many
Pentane.
carbons? How many is it? 1, 2, 3, 4, 5.
So it would start with pence, Miss.
It would start with pent. And what would it end in?
"Ane."
Ane. Very good. Pentane is the name of this compound. All right, let's continue. What's the name of this compound? Well, first of all, just tell me, what would it end in?
Ene, Miss.
It would end in "ene" because of this double bond, and that means it's an alkene. And how many carbons does it have?
3. So it's
3.
propene.
It's propene. And I'm going to tell you that this name is 1-propene, and I will tell you in the future what the 1 stands for. Actually, it's just propene by itself. When I need this propene.
But Miss, it
Alright.
also has a single bond.
Right. But once you see the double bond, it overrides everything, because this double bond is what is going to determine the chemical properties. You understand? So once you see
Yes,
a double bond,
Is it because it comes before or just because it's bigger?
because it's there. Once it's there, it exists at all inside the compound, it is going to cause the compound to behave a certain way. As a result, once the double bond is there, it is automatically in the alkene family. Understood?
Yes, Miss.
All right, so let us look at this one now. Tell me the name of this compound. What's
Miss
the name of it?
Propanol.
It's called propanol. Propanol. Why? Because it has 1, 2, 3 carbons, and the OH group means it's from what homologous series? OH group means it's an alcohol, and alcohols all end in anol. All right? Do you need me to do one more?
No, Miss.
All right, good, because my battery is completely dead. All right, so today we learned about homologous series, and we learned about 4 homologous series. We learned about alkanes, alkenes, alcohols, and alkanoic or carboxylic acids. Alkanes have what kind of functional group? Alkanes have carbon-to-carbon single bonds. Alkanes have carbon-to-carbon single bonds. What about alkenes? Alkenes have what kind of functional group?
Double bond.
Double bonds, carbon-to-carbon double bonds. Alcohols have what functional group?
Hydroxyl group.
The hydroxyl or the OH group. And alkanoic acids have the carboxyl group, which is the C double bond OOH. All right. And you also learned that you have prefixes that go with the number of carbons inside the compound. If you have 1 carbon, it's meth, 2 F, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. All right. So the next time you come, we are going to talk about how to determine the homologous series, how to determine which group. Is it an alkane? Is it an alkene? Is it an alcohol? Is it a carboxylic acid? How do we determine it? And then we will also practice some more naming. Do you have any questions for me before we go?
No, Miss,
Any
but I just
questions?
want to remind you to send the pictures of the example also.
No problem. I'm gonna send all the pictures right now to the group. All right. Anybody else? Any questions? All right. So please, guys, we're forging ahead. I want you to make sure that you're at all the classes and ensure that you go and rewatch the videos if you're having any trouble with comprehension. I'm also available on WhatsApp, as you know, to answer any questions that you have. I'm going to be also sending a practice activity for you in the group right now so that you can practice what we have studied today. All right?
Okay, Miss.
Okay, have a peaceful and productive rest of your day. I don't know when my exam is. I'm so sorry. I have no idea. All right. Take care,
Bye.
everybody. Bye.